Hi everyone. In this video we're going to be going through transformations of cubic functions, and these transformations apply for any graph. You can do it with linear, with quadratic, with cubics, with quartics, but in this video we're going to be looking at the cubics. So transformation is pretty much a fancy way of saying that we're going to move the graph. Okay, so we're given an original graph like y equals x cubed, and we're going to state the transformations or the movements needed to change that graph into another graph. So I'll just find an example. So down the bottom here, this example here is one we'll be using later. You can see that it's in power form, okay? And all the transformations that we'll be doing in this course will be power form. So either turning point form for quadratics, that point of inflection form for cubics. Okay, so just keep an eye out for that. And you can see my cubic graphs there. My original one is in red in the middle. Okay, and these ones have been transformed to the right. These ones have been transformed to the left. Okay, there's also the option of transforming them up, like that, or transforming them down. Okay, we can even flip them over. So we might transform something to rotate around the y-axis. Okay, so there are a series of movements that we're trying to get that original function to another function. Okay, and there'll normally be 1, 2, 3 kind of movements. There'll normally be multiple, not just one. So down the bottom there you can see what would be a typical question in this course. So for the below function, state the transformations required to produce this graph. Okay, and you'll have to make a list of all the movements needed to get to that graph. Okay, luckily for you, it's actually on your formula sheet. Okay, so this is taken from the first page of the formula sheet, and it tells you the wording in particular and what's going on. So if you've got, so we can recognize these bottom two, these are from the point of inflection. If you've got a plus h in there, okay, you translate the graph h units to the left. So if that was x plus 4, you'd translate the graph 4 units to the left. Okay, if it was -2, translate the graph 2 units to the right. Okay, so if it's negative, it's the opposite. Okay, these ones up here reflect it, so they kind of flip it over, turn it around. These two here are dilations, so they're how steep it is, okay, or how flat it is. And these ones down here are moving it to the left and the right and up and down. Okay, so they don't kind of alter the graph, they just move it around. These top two flip it around, and the middle two make it steeper or skinnier, that kind of thing. You do these questions in a test or in an exam, you'll be using that exact wording. Okay, you have it there on your formula sheet. You need to make sure you're using word for word that. You're just changing kind of H and K and maybe left and right. Okay, so make sure you're using that wording. Okay, so here I've got an example and a pretty typical question of what you'll be asked. So for the below function, state the transformations required to produce this graph. So I've got my cubic function here, which is in power form. Okay, I've got my just general power form function, I guess, that I've just taken off the formula sheet so you can see. And I've also got the graphical transformations off the formula sheet as well. Okay, so I'm going to go through one by one, and I'm going to kind of dot point what transformations are needed. I'm going to start at the end over here. Okay, and that is K. So I'm going to go down this list and I'm going to find where it says K here. So plus K is a translation of the graph by K units upwards. So this is positive, so we're going up. So my first dot point, translate the graph 2 units upwards. I'm sorry. I've already marked up the wording. Let me start that again. So translate, my hand's over my formula sheet and I can't read it. Translation of the graph by 2 units upwards. Okay, so I'm copying that wording word for word. Couldn't see it before, I've moved my hand. So it is a translation of the graph by 2 units upwards. Okay, so I've just copied that. Okay, let's do another one. Let's do this -2 here. So we're looking at h. So I'm going to go down, I'm going to find h. There it is there. So that's plus h, and that's moving it to the left. Okay, we've got a -h, so we're going to be doing the opposite. We're going to be moving to the right. Okay, so translation of the graph by 2 units to the right. Okay, see how I didn't do -2 units to the right? Okay, we're changing the direction it's going, not the distance. So it's still going 2, it's just going the opposite way. So instead of going 2 to the left, it's -2, so it's going 2 to the right. Okay, and we've got kind of one number left there, do that in red. We've got the 2 at the front, which is A. So we're going to look down here, and we've got 2 here that it could be. Okay, and it's that one there, it's out the front of the X. So we are going dilation of the graph. I'm just copying word for word. Dilation of the graph by a factor of 2 in the direction of the y-axis. Okay, and that's it, I'm done. Okay, so the other options that we could have is a number in front of the x, or number in here, okay, which would be a dilation of 1 over a in the direction of the x-axis. We could also have a negative out the front, so this was -2. You'd have to put in there that it's reflected around the x-axis, and if there was a negative number in front of the x here, you'd have to do that it's a reflection in the y-axis. Okay, so they're the other options. But that, for a question like that, is the answer. So these will normally be part of a bigger question, possibly a graph this kind of question where you have to find x-intercepts, y-intercepts, state the point of inflection, and state the transformations required. Okay, so it's normally part of a bigger question, but you might just get one like that, and it's just dot pointing and copying the wording exactly off your formula sheet.